Hello everyone, let's continue by adding the movement to our character, and let's start by going to the sources data, and then in the game settings data we are going to add a couple of variables here. So double click it to open it in Visual Studio. Once open, we are going to add in our player settings a public float, movement speed, and public float rotation speed. Speed, if I can spell it right. And these are the two data that we are going to work with now. So we can now see that we need a movement component and a rotation component to create. So let's let Unity compile, and let's go into our components folder, game. And in here we are going to create a couple of components. So let's go to create Entitas component, and let's call this movement component. Actually no, let's call it movement speed component. So we can right away bind it to what it's doing. So movement speed component, and as you guessed it, we need also the rotation speed component. Create Entitas component rotation speed component. So if you remember, if we leave the components empty as they are now, they will be treated as a flag component, like do I have a rotation speed, do I have a movement speed, but there is no value to be passed to the other systems. So we need to change that. Double click the movement speed component, and let's wait for Visual Studio to open. Once open, we can leave the context to game, it is okay. So let's add here a little information just to remember a couple of months later on. So this is the movement speed of the local player, and in here we can add our public float value. Save it, and let's do the same for the rotation speed component. This is the rotation speed of the local player. And in here again we add a public float value. Minimize or close Visual Studio, and let's wait for Unity to compile this. Once compiled, we can now go into our systems folder, then game subfolder, and here we are going to create our move player system in the first place. So let's right click, create Entitas, and then we choose execute system, and let's call it move player system. Let's wait for Unity to compile, double click it to open the script. So once it is open, we need to include our using Unity engine, and also let's add a little description here explaining. So this system moves the player according to the move input and because we are using rigid body, this system has to run in fixed update. So we need here, instead of the list of all the contexts, we only need the game context. Let's rename this one to game context. It can be read-only. Also we need our input context, of course. Let's fix this constructor here. So context.game, then our input context, we get it from the context global input. Input. And also we need the camera from the scene in order to have the right direction to face the player. So let's add a variable here, private transform camera object. So camera object is going to be camera main transform. We could also pass the camera here in the constructor, then register it when we bind the system into the controller. But let's do it like this for now. Now in the execute method, we want first of all to make sure that this player is the local player. So if game context is local player, then we can proceed to add our logic for the movement. So we retrieve the game entity of the local player, game context, local player entity. From here we get the vector2 of the input system. Input context, move input, value. Well, I see I'm using lower cases here. This will retrieve the up, down, left and right. And then we need to build a vector tree for the move direction or movement direction, clumsy fingers, based on the forward vector of the camera, or the forward direction of the camera, sorry. So axis value Y, and then this move direction we need to add the camera object right vector plus axis value X. Then we normalize this vector we don't care about the up movement or direction, and at the end we add up local player. Oh, I call it game entity. Okay, let's call it local player, the game entity. You can see that we don't have the movement speed yet. That was my mistake because I forgot to compile the components. So let's comment this out for now, save it. Let's go back to Unity, let it compile. Yeah, every time you create a new component you need to compile that component using Geni, whether generate from the menu tools Geni generate or shift Ctrl G. So let's do that. I don't know why Visual Studio does this, but now we can see it under our generated folder. Then by context we have game components, and then we have our wrappers, game movement speed and game rotation speed component. That's what we need. So let's go back to Visual Studio. So move player component. So if we remove the comment, now we have movement speed, and we need the value. After building our move direction vector tree, we can then local player retrieve the rigid body value and add the velocity out of the move direction. Rigid body and the velocity of the rigid body. So let's close Visual Studio, let Unity compile, and let's add our move player system to our what is it, mono behaviors, our sandbox system here. So let's double click on the sandbox system. And in the previous video we created this list of systems and container for the context, and if you remember that we set the movement component, since the system movement system, since we are using physics and rigid body, it needs to run under the fix update method. So let's create a private systems physics systems, so we can group all the systems that has rigid bodies or other kind of physics logic that needs to be executed in the fixed update. Now we have here in the context, we retrieve the shared instance of the context. We create a feature, so let's add here our new physics system equals new feature, physics systems. We spawn the point system, we create the local player, and then we create or we add our physics system, add new move player system, and this requires the context. In the start method, we add our physics systems initialize, even though we don't have any initialization system right now for it, but it's a good practice just in case we forgot later on if we add any initialization. So it's already there. So, since our system doesn't have any, it will be called, but nothing will happen, so it's okay. We have the update, so we need to add now the private void fix update, and from here we do the same as before. So if physics system execute and physics systems cleanup to make sure that resources not used are removed from the thread. Okay, in order to test, we need to go back into our data. So we have data settings. Our object that we create is movement and rotation speed. So let's add those here. This is the one I test and work for me. 4.5 for movement speed and 15 for rotation speed. So now we can query the game systems, game settings, and that is done in our what is it? Game system create local player system. So we need to add these two new components to the local player, the movement speed and the rotation speed. So remember that the order matters. For that, let's see, we have the settings context. That's good. So after adding the component rigid body, let's do local player add movement speed, and we need to pass the default value. So this one we can get it from the settings context. Game settings, value, player config, and movement speed. I will copy the full line and just change here for add rotation speed and change the movement speed by rotation speed. Now it should work, so let's go back to Unity. We are already in the bootstrap scene, so let's hit play. We are connected to photon and we have movement. Ctrl P to exit the play mode. Let's build another instance to test it replication in multiplayer. So let me open. I always like to build using an empty scene for reasons. So let's see, build the settings, build, and let's wait for it to build. So it's already compiled. So let's execute one instance here and double click to execute another one. Let's start this one. So creation is still working. So if I click on this one and move, you can see I'm moving. If I click on that one, we have movement and it's been replicated. So let's continue by adding the rotation. Following the same steps, for the rotation system, we go to the Systems folder, Game, Move Player System, then we need to add a new one, Create, Entitas, Execute System, Rotate, Player System. Let's open up in Visual Studio, and we need to add our using Unity engine, and let's add a comment here. So this system rotates the local player according to the move inputs. Again, because we are using a rigid body instead of the character controller or any other type of character, this system has to run on fixed update. Again, this one needs to be, let's do it read only. I will change the template actually to make it always read only. Game context. I'm going to rename this one to game context, and from here we query just from the context list the game context. As before, we need a private read-only input context, and also the camera transform reference, transform camera object. There we go. So in the constructor, input context, context input, camera object, camera main dot transform. Alright, so in the execute, once more, we need to make sure that we are dealing with the local player. If game context is local player, then we are good to proceed with our logic. We need to retrieve the local player game entity out of the game context local player entity. We need to retrieve the access value from the input context, move input value, and we build our vector tree target direction. This is very similar to the previous logic we wrote, but this will affect only the rotation. So access value dot y, target direction will be to the target direction, plus camera object dot right access value dot x. Then we normalize this vector. Once again, we don't care about the up direction. So if our target direction equals 0, we set the target direction to our local player game view. The game view, remember, this is the game object living in the local player. We query the transform and we set it to the forward direction if we are not moving at all. This is just to remember the direction we were left after moving the player. So for the rotation, we need to have a quaternion target rotation look rotation, and that will be our target direction. Then we need another quaternion for the player rotation, and we are going to slurp to it local player game view. We get the transform rotation, so we need the initial rotation to where we need to rotate and the time for the rotation to happen. So in this case we get the original, the initial rotation. We set the target rotation is our final rotation, and the duration is our rotation speed. So it's stored in the local player. Rotation speed we have there, dot value times time fixed delta time. Remember, we are in the fixed update here. Okay, so after having our build our quaternion player rotation, we can then assign it to our local player game view transform rotation equals player rotation. So we have built our RotatePlayer system. Now we need to register it into our Sandbox systems. We already have physics systems here, so it's just a matter of, in this line after the move player system, we add our physics, add new rotate player system, and we need to pass the context. Since we are already querying two times the camera main transform, I think it's a good idea just to pass it the reference of the camera here in the constructor. But let's play it and fix it up later on. So we have everything saved. Let's go back to Unity, let it compile. And let's go back to the Sandbox scene. Sorry, the bootstrap. And hit play. We have movement and we have rotation. Awesome. So to prove this a little bit out, if we go back into our Sandbox system, and let's comment out the move player. Let's hit play the bootstrap again. We don't have movement, only rotation. So this is good to debug. If something is not working in one system, you can go right away to which system is failing to work, and it's easy to fix then. And lastly, let's build a new executable to test this with multiplayer. After building, let's open a couple of instances. Remember, this is happening because the camera, we are not add any logic yet to bind the camera to the local player, so that's why we have two fixed spawn spots. And if I click on the first instance, you can see that we have movement and rotation, and is replicated across the network. So if I click on this instance now, the same happens. Nice. So thank you for watching, and on the next video we are going to implement the logic for the camera to follow the player. Thanks again, and see you next video.